The Venn diagram shows the sets P and Q contained in the universal set. List the elements in the set P union Q. Now, P union Q means that we want all of the elements in P and Q combined with no repeats. So we're going to list all the elements of P and all the elements of Q, and we're going to put them in one set with no repeats. So first, what are the elements of P? Well, the elements in set P are Y, T, W, and A. Indeed, this circle represents the set P. This large circle represents the set P. And all of the elements inside this big circle are elements of P. So Y is an element of P, T is an element of P, W is an element of P, and A is an element of P. So those are the elements of P, Y, T, W, and A. Now, what are the elements of Q? Well, the elements of Q are T, W, A. Notice this smaller set, right? This smaller set Q. This set contains the elements T, W, and A. So set Q contains the elements T, W, and A. Notice that the situation that we have here is we have that Q is a subset of P. And we know that Q is a subset of P because all of the elements that are inside Q are inside P, because Q literally lies within set P. So set Q is a subset of set P. So T, W, A, all of those elements inside Q are also elements of P. Now, what is the union of P and Q? Well, the union is going to be all of these elements combined with no repeats. So let's combine them. So P union Q is going to be Y, T, W, and A. And so that's the union. And so the answer for this one is Y, T, W, A. Those are the sets. Those are the elements in the set P union Q. Next, the question states, list the elements in the set P intersect Q. P intersect Q. Now, when we're looking at P intersect Q, we're looking at all of the elements inside P and Q that are common, that are alike. So let's list the elements in set P. Those are Y, T, W, and A. Those are the elements in set P. The elements in set Q are T, W, A. Now we have to circle all of the elements that are in common, that are alike in both sets. So T is the same in both sets. W is in both sets, and A is in both sets. And so that means that the intersection, P intersect Q, is going to contain the elements T, W, A. And so that's our answer. T, W, A. The elements T, W, A are part of the set P intersect Q. Next, the question states, list the elements in the set Q complement. Q complement. Now, Q complement means that we want all of the elements in the universal set except for the elements that are inside Q, which means that we do not include any of the elements that are inside Q, but all of the other elements that are in the universal set we include. So we do not include T, we do not include W, and we do not include A because they are part of Q. We don't want them, right? We only want all of the elements that are not part of Q. So that would be X, Z, and Y. So those are going to be the elements that are inside of Q complement. Y, X, and Z. Those are the elements inside Q complement. Next, the question states, write down the value of the number of elements in P. That's what this means, the number of elements in P. Now, what are the elements in P? Well, Y is in P, T is in P, W is in P, and A is in P. So Y, T, W, and A, and those are the elements in P. How many elements are in P? That's 1, 2, 3, 4. So there are 4 elements inside the set P. Next, the question asks us to determine the value or to write down the value of the number of elements in P complement intersect Q complement. First, let's determine what are the elements in P complement. Now, if we're looking for P complement, that means that we are going to include all of the elements in the universal set except for any of the elements that are inside P. Again, for P complement, we want all of the elements in the universal set except for the elements that are inside P. So we do not include any of the elements inside P. And so that means that we cannot include Y, T, A, or W. So the only elements in P complement is going to be X and Z. So those are the elements of P complement, X and Z. Okay, now that we know what is P complement, let's determine Q complement. Now, what is Q complement? Well, Q complement means that we want all of the elements in the universal set except for the elements that are inside Q. So that means that we do not include any of the elements that are inside Q, but all of the other elements in the universal set we can include. So what do we have left? We have X, Y, and Z, or Y, X, and Z. Those are going to be the elements in Q complement, Y, X, and Z. So now we have the set P complement, and now we have the set Q complement, but we want the intersection of these two sets. We want the elements that are in common in both sets. And so we have X is common in both sets. We have Z is common in both sets. So X and Z are both common. And so that means that P complement intersect Q complement is XZ. So how many elements are inside P complement intersect Q complement? Well, there's only two elements, X and Z. And so the answer here is 2.